Hello, in this lecture we'll answer on two questions. The first question, we find out the graph of tangent MF that is equals to x. And the second question, we find out the graph of this tangent AP that is also equals to x. So I start with the first question. In the domain we have three identical circles, and we also have the big tangent ABC. The big tangent ABC is tangent to this circle at this point A, it's tangent to this middle circle at this point B, and it is tangent to this circle at point C. In addition, we have here, this is the common sum point M. From this common sum point M, we have tangent MD, that is tangent to this circle at point D. The graph of this tangent MD is 5 units. In addition, we have also tangent ME, that is tangent to this circle at point E. The graph of tangent ME is 7 units. And finally, we have also tangent MF, that is tangent to this circle at point F. The graph of tangent MF is x, and our mission is to find out the graph of tangent MF that is equals to x. We have to find out the value of x. So, we also know that this is line segment AB that is equals to 3 units in its length. This is line segment BC that is also equals to 3 units in its length. So first of all, we define the center of this circle. This point is point P. And we define the center of this middle circle. This point is point Q. And finally, we define the center of this circle. This point is point S. In the next step, we join points P and D together by straight line. Point P is the center of the circle, point D is the point of the circle itself, therefore PD is the radius of this circle. We define the radius of this circle as R. So PD equals to R, and because of the fact that the radius PD is drawn to point D, that is the point of tendency of tangent MD with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent MD will be perpendicular to the radius DP. If MD is perpendicular to DP, it means that this angle equals to 90 degrees according to rule 1. In the next step, we will join points M and P together by straight line. By joining points M and P, we get the right triangle MPD. So in the next step, we'll implement the Pythagoras theorem on this right triangle MPD. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle MPD is MP, therefore the square of the hypotenuse is MP square, and MP square must be equal to PD square plus DM square. So I write it down. So MP square, that is the square of the hypotenuse, equals to PD square plus MD square. Then again, according to equation 1, we found out that MP square equals to PD square plus MD square. MP is the missing side, so we leave it as it is, so it is MP square equals to PD square. PD is R, therefore PD square is R square plus MD square. MD equals to 5 units in its length, therefore MD square is 5 squared, that is 25. So in total, actually, according to equation 1, we found out that MP square equals to R square plus 25. We repeat on the same process on this middle circle, that is to say we join points Q and E together by straight line. QE is the radius of this circle. Because of the fact that all those three circles are identical, the radius of this circle is equal to R. Well, the radius of the other of those three circles, they are all equal to R. So QE equals to R, and according to rule 1, this angle is a right angle. We join points Q and M together by straight line. By joining points Q and M, we created the right triangle, MQE. So the next step, we implement the Pythagoras theorem on this right triangle, MQE. According to the Pythagoras theorem, in this right triangle MQE, MQ squared, that is the square of the hypotenuse, is equal to QE squared plus EM squared. Okay, again, according to the Pythagoras theorem, in the right triangle MQE, MQ squared equals to QE squared plus EM squared. MQ is the missing side, so we leave it as it is, so it is MQ squared equals to QE squared. QE is out, therefore QE squared is R squared plus EM squared. EM is 7, therefore EM squared is 7 squared, that is 49. So in total, according to equation 2, we actually found out that MQ squared equals to R squared plus 49. We repeat the same process on this right triangle, right circle. We join points S and F together by straight line. SF is the radius of this circle, that is R, and according to rule 1, this angle equals to 90 degrees in its size. We join points S and N together by straight line. By joining points S and M, we created the right triangle, MSF. The next step, we'll implement the Pythagoras theorem on this right triangle, SMF. According to the Pythagoras theorem, in this right triangle, SMF, MS squared, that is the square of the hypotenuse, is equal to SF squared plus MF squared. And again, according to the Pythagoras theorem, in this right triangle MSF, MS squared equals to SF squared plus MF squared. MS is the missing side, so we leave it as it is, so it is MS squared equals to SF squared. SF is out, therefore SF squared is R squared plus MF squared. MF is X. This is the tangent that you are looking for in this question. MF is X, therefore MF squared is X squared. So in total, according to equation 3, we actually found out that MS squared equals to R squared plus X squared. In the next step, we will join points P and A together by straight line. P PA is of course the radius of this circle, that is R, and according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, we join points Q and B together by straight line. QB is of course the radius of this circle, this is R, and according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. And finally, we join points S and C together by a straight line. CS is of course the radius of this circle, that is R, and according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Those 3 points P, Q, and S, they are at the same distance from the straight line ABC. Again, the 3 points P, Q, and S, they are at the same distance from the straight line ABC. Usually the distance of point P from ABC is R, the distance of point Q from the straight line ABC is R, and the distance of point S from the straight line ABC is also R. So those 3 points are at the same distance from the straight line ABC. And therefore, those 3 points P, Q, and S must be located on one straight line. That is to say, PQS is one straight line. Exactly for the same reason that the 3 points P, Q, and S are all at the same distance from the straight line ABC. Therefore, the straight line PQS must be parallel to the straight line ABC. Okay, the straight line PQS must be parallel to the straight line ABC. So here we can implement rule 17. So we can quickly on rule 17. According to rule 17, the sum of one-sided interangles that are located between parallel lines is equal to 180 degrees. So in the domain we have line A that is parallel to line B. The red line is line C that intersects with the 2 lines A and B, those 2 points. In addition, we have here the 2 angles alpha and beta. Those 2 angles alpha and beta, they are both located on the right side of the red line C, and therefore they are defined as one-sided interior angles, one-sided angles. And because of the fact that those 2 angles alpha and beta, they are both located between the parallel lines A and B, they are also defined as an interior angle. So those 2 angles alpha and beta, they are defined as one-sided interior angles. And according to this rule 17, the sum of 2 one-sided interior angles is equal to 180 degrees. That is to say, alpha plus beta equals to 180 degrees according to this rule 17. So we can implement rule 17 in our domain. Why? Because in our domain, those 2 angles, they are both defined as one-sided interior angles. And because of the fact that those 2 angles are located between the parallel lines PQS and ABC, the sum of those 2 angles must be equal to 180 degrees according to rule 17. But this angle equals to 90 degrees according to rule 1. So 90 degrees plus this missing angle, in total the sum of those 2 angles must be equal to 180 degrees. Therefore this missing angle must be equal to 90 degrees in its size. Those two angles are also defined as one-sided interangles, and because of the fact that those 2 one-sided interangles are located between the parallel lines PQS and ABC, the sum of them must be equal to 180 degrees. But this angle equals to 90 degrees according to rule 1. So 90 degrees plus the size of this missing angle, in total the sum of those 2 angles must be equal to 180 degrees, therefore this missing angle must be equal to 90 degrees in its size. Likewise, those two angles are also defined as one-sided interangles. So this angle equals to 90 degrees. 90 degrees plus this missing angle, in total the sum of those two angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. And finally, those two angles are also defined as one-sided interangles. This is a right angle according to rule 1. That is to say, so 90 degrees plus this, the size of this missing angle, in total the sum of those two angles must be equal to 180 degrees according to rule 17. Therefore, this missing angle must be equal to 90 degrees in its size. So inside this quadrangle PQBA, we have 4 right angles. According to rule 5, any quadrangle that has 4 right angles must be a rectangle if not a square. So we relate to this quadrangle PQBA is a rectangle because it has 4 right angles. So this quadrangle PQAB is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in this rectangle PQBA, side AB must be equal to the opposite side PQ. But AB is 3 according to what is given as the equation, therefore the opposite side PQ must be also equal to 3 units in its length. Inside this quadrangle QSCB, we have 4 right angles. And according to rule 5, any quadrangle that has 4 right angles must be a rectangle if not a square. So we relate to this quadrangle QSCB is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle QSCB, side BC must be equal to the opposite side QS. But BC is 3, therefore the opposite side QS must be also equal to 3 units in its length. In the next step, I'll copy the big triangle MPS in the new page and we'll analyze this big triangle MPS. So actually, this is the big triangle MPS that I call it from the original drawing. Line 7 MQ is the median of this triangle MPS. So write it down. So line 7 MQ is the median of this triangle MPS. So what is a median? A median is a line segment that connects the vertex to the opposite side PS, to the midpoint of the opposite side PS. Here the vertex is M, and it connects the vertex M to the opposite side PS. It actually connects the vertex M to the midpoint of the opposite side PS. The midpoint of PS is Q, so it connects point M and Q together by straight line. At point Q, side PS has been bisected into two halves. The first half is PQ and the second half is QS. So the median MQ bisects the opposite side PS into two halves. But the question is, what is the length of the median MQ? So here we have a special formula for the median MQ. What is the length of a special formula that will help us to calculate the length of the median MQ. So in the drawing we have triangle ABC. The length of side AB is B units, side AC equals to C units in its length, and side BC equals to A units in its length. AD, line segment AD, is the median of this triangle ABC. It exits starts from point A, that is the vertex A, and ends at midpoint of the opposite side BC. The midpoint of the opposite side BC is D. At point D, side BC has been bisected into two halves. Each half equals to BC over 2. So BD equals to DC equals to BC over 2. So the median AD bisects the opposite side BC into two halves. But what is the length of the median AD? AD equals to the square root of 2b squared plus 2c squared minus a squared over 2. So again, the length of the median AD is equal to the square root of 2b squared plus 2c squared minus a squared over 2. So we use this new formula in order to find out the length of the median MQ. According to the new formula, the length of the median MQ is equal to the square root of 2 times MP squared plus 2 times MS squared minus PS squared divided by 2. This equation is the implementation of the length of the median in our triangle MPS. So here we multiply this equation 1 by 2, and we get that according to equation 1, 2 times MQ equals to the square root of 2MP squared plus 2MS squared minus PS squared So actually, after we multiplied this equation 1 by 2, we actually found that 2 times MQ equals to the square root of 2MP squared plus 2MS squared minus PS squared. Here we'll square both sides of this equation 1. So 2 times MQ squared is 2 squared, that is 4 times MQ squared. So this is 4 times mq squared. We'll square also this side of equation 1. And because of the fact that the square cancels the root, we left only what is inside the root. We left only with 2 times mp squared plus 2 times ms squared minus ps squared. So we have here, according to equation 1, we can find out that 4 times mq squared. mq squared, according to equation 2, mq squared equals to r squared plus 49. Therefore, we substitute mq squared here by r squared plus 49, and it is equal to 2 times mp squared. According to equation 1, mp squared equals to r squared plus 25. Therefore, we substitute mp squared here by r squared plus 25. And we have also here 2 times ms squared. 2 times ms squared. So, but ms squared, according to equation 3, ms squared equals to r squared plus x squared. Therefore, we substitute ms squared here by r squared plus x squared. And we have also here minus ps squared. ps in total equals to 3 plus 3, that is 6. Therefore, ps squared is 6 squared, that is 36. Here we'll open the brackets on both sides of this equation, equation 1, and we get that four r squared, and we have here 4 times 49, that is 196, so it is plus 196, equals to 2 times r squared, plus 2 times 25, that is 50, that is plus 50. We have also 2 times r squared plus 2x squared minus 36. So in this side of the equation we have 4r squared. In the other side of this equation 1 we have 2r squared plus 2r squared, that is also 4r squared. So we subtract 4r squared from this equation. And after we subtract 4r squared from this side of this equation 1, 4r squared will get cancelled, and we left only with 196. On the other side of this equation 1, 2r squared plus 2r squared is also 4r squared, so those two expressions will also get cancelled. And we left only with 50 minus 36, that is 14. Plus 2x squared. So in total, according to equation 1, we should find out that 196 equals to 14 plus 2x squared. Here we subtract 14 from this equation, equation 1, and finally we get that 196 minus 14 is 182, so 182 equals to 2x squared. Here we divide this equation, equation 1 by 2, and finally we get that 182 over 2 is 91, so 91 equals to x squared. Here we take a root out of this equation, and finally we get that x equals to the square root of 91, and the square root of 91 is 9.54 units. That is the answer to the question. So we found out that the length of this standard MF that is equals to x, it is equals to either the square root of 91 units. In terms of numbers, the length of this standard MF that is equals to x is equal to 9.54 units. So we finish with the first question. In the next step, I'll present to you the second question, and we will solve the second question of this lecture. Our definition in this second question is to find out the length of this tangent AP that is equals to x. We have to find out the value of x. So in the domain we have quarter circle AOB. Inside this quarter circle AOB we have this small circle. The small circle touches the big quarter circle here at this point. This is the touching point, so we define the touching point, this point is point K. We define the center of this small circle, this point is point C. And we join point C and Q together by straight line. CQ is of course the radius of this small circle. We define the radius of this small circle as A, so CQ equals to A. According to our definition, we define the radius of this big quarter circle as B. So OB is the radius of the quarter circle that is equals to B units in itself according to our definition. AO is also the radius of this quarter circle that is equals to B units in its length. Point Q is the point of tendency of tangent OB with this small circle. Therefore, according to rule 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. In the next step, we'll join points P and C together by a straight line. PC is of course the radius of this small circle that is equal to A. Point P is the point of tendency of tangent AP with this small circle. Therefore, according to rule 1, this angle equals to 90 degrees. In the next step, we join points A and C together by a straight line. By joining points A and C, we get the right triangle, triangle APC. So in the next step, I copy the right triangle APC in the new page and we will implement the Pythagoras theorem on this right triangle, triangle APC. Here by PT is the abbreviation for Pythagoras theorem. So really this is the right triangle APC that according to the original drawing, according to the Pythagoras theorem, this right triangle APC, AC squared, that is the square of the hypotenuse, equals to AP squared plus PC squared. So I write it down, this will be equation 1. AC squared, that is the square of the hypotenuse, is equal to AP squared plus PC squared. AC is the missing side, so we leave it as it is, so it is AC squared equals to AP squared. AP is x, therefore AP squared is x squared plus PC squared. PC is a, therefore PC squared is a squared. So in total, according to equation 1, we actually found out that AC squared equals to x squared plus a squared. As I already mentioned before, we have an internal notch between the small circle and the big quarter circle, that is to say they touch each other internally in this point K. And whenever you have an internal notch between two circles or semicircles or quarter circles or whatever, you can implement rule 9. So let's click on rule 9. According to rule 9, if two circles touch each other internally, then the straight line that connects their centers together passes through their touching point. In the drawing we have two circles. The center of this big circle is 0.0. The center of this small circle is 0.m. And the straight line that connects the centers together is of course the straight line OM. And according to this rule 9, the straight line OM must pass through the touching point, that is point P. Again, according to rule 9, the straight line OM must pass through point P, that is the touching point. Or OMP is one straight line. Again, according to this rule 9, OMP is one straight line. So we can implement rule 9 in our drawing. Right, put in our drawing. We have an internal notch between the small circle and the big quarter circle at point K. Therefore, we can implement here rule 9. The center of this big quarter circle is 0.0. The center of this small circle is 0.c. And the straight line that connects the centers together is of course the straight line OC. And according to rule 9, the straight line OC must pass through their touching point, that is point K. Again, the straight line OC, according to rule 9, must pass through point P, that is their touching point. Or OCK is one straight line. Again, according to rule 9, OCK is one straight line. So we join points O and C together by straight line, and the straight line OC must pass through point K, that is their touching point. From the drawing, it is very easy to see that indeed the straight line OC passes through point K, that is their touching point. CK is the radius of this small circle, that is equals to A. Line segment OK is the radius of this quarter circle, that is equals to B. What is the length of line segment OC? For the drawing, it is very easy to see that OC in total equals to OK minus CK. Again, OC equals to OK minus CK. So I write it down. OC in total equals to OK minus CK. So OC in total equals to OK, that is B, is the radius of the quarter circle, that is B. Minus CK. CK is the radius of the small circle, that is A. So in total OC equals to B minus A units in its length. In the next step, I will copy the right triangle OCQ in a new page, and we will implement the Pythagoras theorem of this right triangle, triangle OCQ. Here by PT is the evaluation for Pythagoras theorem. The hypotenuse OC equals to B minus A units in its length. side OQ equals to 5 units in its length according to what is given as the question. And this side CQ equals to A units in its length. It is the radius of this small circle that is equal to A units. So actually, this is the right triangle OCQ that according to the original drawing. This right triangle OCQ, according to the Pythagoras theorem, OC squared, that is the square of the hypotenuse, equals to CQ squared plus QO squared. So I write it down. This will be equation 2. OC squared, that is the square of the hypotenuse, is equal to CQ squared plus OQ squared. The hypotenuse OC equals to B minus A, therefore OC squared is B minus A squared, and it is equal to CQ squared. CQ is A, therefore CQ squared is A squared plus OQ squared. OQ is 5, therefore OQ squared is 5 squared, that is 25. So in total, according to equation 2, we have found out that B minus A squared equals to A squared plus 25. B minus A squared is B squared plus A squared minus 2 times A times B, and it is equal to A squared plus 25. So here we have A squared on both sides of this equation too, so A squared will get cancelled. After we cancel A squared in this side of equation 2, this equation 2, we left only with B squared minus 2AB. And the other side of this equation 2, we left only with 25. So in total, according to equation 2, we actually found out that B squared minus 2AB equals to 25. In the next step, we will do a construction. That is to say, from this point C, we will go perpendicular on AO. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point C and AO. This point is point N. By doing this construction, we're going to do quadrilateral NCQO. Inside this quadrilateral NCQO, we have 1, 2, 3 arcangles. The sum of 3 arcangles is 270 degrees. So 270 degrees plus the size of this 4-15 angle, in total they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this 4-15 angle must be equal to 90 degrees in its size. So inside quadrilateral NCQO, we have 4 arcangles, and according to rule 5, any quadrilateral that has 4 arcangles must meet this rectangle in front of square. So we write to this quadrilateral NCQO as a rectangle because it has 4 arcangles. So I write it down. This is quadrilateral NCQO, that is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So here in rectangle NCQO, side OQ must be equal to the opposite side NC, but OQ is 5, therefore the opposite side NC must be also equal to 5 units in its length. Likewise, according to the same rule, in the same rectangle NCQO, side CQ must be equal to the opposite side NO, but CQ is Z, therefore the opposite side NO must be also equal to A units in its length. What is the length of the missing line segment, line segment AN? From the drawing it is very easy to see that AN in total equals to AO minus NO. Again, AN equals to AO minus NO. So I write it down. AN equals to AO minus NO. So AN in total equals to AO, that is B, it is the radius of the contact circle that is equals to B, minus NO. NO equals to A. So in total, AN equals to B minus A units in its length. AN equals to B minus A units. So in the next step, I'll copy the right triangle, triangle A and C in the new page, and we will implement the Pythagoras theorem on this right triangle, triangle A and C. Here by PT is a version for Pythagoras theorem. So actually, this is the right triangle A and C, that is the coverage from the original drawing, according to the Pythagoras theorem. On this right triangle, triangle A and C, AC squared, that is the square of the hypotenuse, equals to AN squared plus NC squared. So I'll write it down, this will be equation 3. AC squared, that is the square of the hypotenuse, is equal to AN squared plus NC squared. According to equation 1, we have already found out that AC squared equals to X squared plus A squared. Therefore, we substitute AC squared here by X squared plus A squared. And it is equal to AN squared. AN is B minus A, therefore AN squared is B minus A squared. Plus NC squared. NC is 5, therefore NC squared is 5 squared, that is 25. So in total, according to equation 3, we actually found out that X squared plus A squared equals to B minus A squared plus 25. So X squared plus A squared equals to B minus A squared. B minus A squared equals to B squared plus A squared plus 2 times A times B plus 25. So here we have A squared on both sides of this equation. Equation 3, so A squared will get cancelled. After we cancelled A squared, in the side of this equation 3 we left only with X squared. And on the other side of this equation 3 we left only with B squared plus 2 times AB plus 25. So according to equation 3, we have found out that X squared equals to B minus 2AB plus 25. But according to this equation, equation 2, B squared minus 2AB equals to 25. Therefore, we substitute B squared minus 2AB here by 25, and we get that X squared equals to, again, B squared minus 2AB is 25 according to this equation, equation 2. plus 25. So in total, x squared equals to 25 plus 25, this is 50. So x squared equals to 50. Here we take a root of this equation and we get that x equals to the square root of 50. So it is the square root of 50, but 50 is 25 times 2. And the square root of 25 is 5. So in total, this expression equals to 5 times square root of 2. 5 times square root of 2 is equal to 7.071 units. And this is the answer to the question. Repeat again, we have found out that the length of this line segment AEP or tangent AEP is equal to x. It is equal to either to 5 times square root of 2 units, or the length of this tangent AEP is equal to x, is equal to 7.071 units in its length. So we finish with the second question. In the next step, I will summarize the lecture. We'll start with the first question, of course. In this first question, our mission is to find out the length of this tangent MF is equal to x units, and it is equal to x according to what is given as the question. We have to find out the value of x. Again, MF is tangent to this circle as point F. So in the domain, we have 3 identical circles, and we have the big tangent ABC. The big tangent ABC is tangent to this circle is here at point A. It's tangent to this middle circle here at point B. And it is tangent to this circle here at point C. In addition, we have this common extent point M. From this common extent point M, we have tangent MD that is tangent to this circle point D. And the length of this tangent MD is 5 units. In addition, from the same common extent point M, we have tangent ME that is tangent to this middle circle here at point E. The length of this tangent ME is 7 units, and finally we have also tangent MF that is tangent to this circle at point F. The length of tangent MF is x, and our mission is to find out the value of x. What is the length of tangent MF? That is x. We have to find out the value of x. So first of all, we define the center of this circle, this point is point P. We define the center of this middle circle, this point is point Q. And finally, we define the center of this circle, this point is point S. In the next step, we join points P and D together by a straight line. PD is the radius of this circle. We define the radius of this circle as R. Therefore, the radius of this circle must be also equal to R, and the radius of this circle must be also equal to R because of the fact that those 3 circles are identical. According to rule 1, MD is tangent to this circle at point D, and according to rule 1, this circle equals to 90 degrees. In the next step, we join points M and P together by a straight line. By joining points M and P, created the right triangle MPD. So in the next step, we implemented the Pythagoras theorem on this right triangle MPD. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse on this right triangle MPD is MP, therefore the square of the hypotenuse is MP square, and MP square must be equal to PD square plus MD square. Repeat again, according to the Pythagoras theorem, in this right triangle MPD, MP square equals to PD square plus MD square. MP is the missing sign, so limiticity, so it is MP square equals to PD square. PD is R, therefore PD square is R square plus MD square. MD is 5, therefore MD square is 5 square, that is 25. So in total, according to equation 1, we have found out that MP square equals to R square plus 25. We repeated on the same process on this middle circle. That is to say, we join points Q and D together by straight line. Q is the radius of this circle, that is equal to R, and according to rule 1, this circle equals to 90 degrees. We join points M and Q together by straight line. MQ is the radius, MQ. So by joining points M and Q together by straight line, we created the right triangle, triangle MQE. In the next step, we implemented the Pythagoras theorem on this right triangle, triangle MQE. According to the Pythagoras theorem, MQ squared, that is the square of the hypotenuse, equals to QE squared plus EM squared. Repeat again, according to the Pythagoras theorem, in this middle right triangle MQE, MQ squared equals to QE squared plus EM squared. MQ is the missing side, so it is, so it is MQ squared equals to QE squared. QE is out, therefore QE squared is R squared plus ME squared. ME is 7, therefore ME squared is 7 squared, that is 49. So in total, according to equation 2, we should know that MQ squared equals to R squared plus 49. We repeated on the same process on this right circle. So that is to say we join points S and F together by straight line. SF is the radius of this circle, that is R. According to rule 1, this angle equals to 90 degrees. And we join points M and S together by straight line. By joining points M and S, we created the right big triangle, triangle MSF. In the next step, we implemented the Pythagoras theorem on this right big triangle, triangle MSF. According to the Pythagoras theorem, in this right triangle MSF, MS squared, that is the square of the hypotenuse, equals to SF squared plus FM squared. Repeat again, according to the Pythagoras theorem, in this right triangle MSF, MS squared equals to SF squared plus MF squared. MS is the missing side, so it is, so it is MS squared equals to SF squared. SF is out, therefore SF squared is R squared plus MF squared. MF is X, therefore MS squared is X squared. So in total, according to equation 3, we should find out that MS squared equals to R squared plus X squared. In the next step, we join points P and A together by straight line. PA is the radius of this circle, this is R. Point A is the point of tendency of tangent ABC with this circle. Therefore, according to rule 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. Likewise, we join points O and B together by straight line. OB is the radius of this circle, that is R. And according to rule 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. And finally, we join points S and C together by straight line. S is the radius of this circle, that is R. The big tangent ABC is tangent to this circle at point C. Therefore, according to rule 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. Because of the fact that those 3 points P, Q and S, they are at the same distance from the straight line ABC, therefore those 3 points P, Q and S must be located on one straight line. That is to say, PQS is one straight line. And exactly for the same reason that PQS, that the 3 points P, Q and S are at the same distance from the straight line ABC, therefore the straight line PQS must be parallel to the straight line ABC. Again, the straight line PQS must be parallel to the straight line ABC. And therefore we can implement here rule 17. So please click on rule 17. According to rule 17, the sum of one-sided interior angles that are located between two parallel lines is equal to 180 degrees. So in the drawing we have line A that is parallel to line B. We have also this red line C that intersects with those two parallel lines A and B and those 2 points. In addition, we have also here angles alpha and beta. Those 2 angles alpha and beta are defined as one-sided interior angles, and according to this rule 17, the sum of two one-sided interior angles is equal to 180 degrees. Therefore, alpha plus beta equals to 180 degrees. We can actually implement rule 17 in our drawing. In our drawing, those 2 angles are defined as one-sided interior angles, and because of the fact that they are located between the parallel lines PQS and ABC, the sum of those 2 angles must be equal to 180 degrees according to rule 17. But this angle equals to 90 degrees according to rule 1. So 90 degrees plus this missing angle, in total the sum of those two angles must be equal to 180 degrees. Therefore this missing angle must be equal to 90 degrees in its size. Likewise, those two angles are also defined as one-sided interangles. Therefore, according to rule 1, the sum of those two angles must be equal to 180 degrees. But this angle equals to 90 degrees according to rule 1. So 90 degrees plus this missing angle, in total the sum of those two angles must be equal to 180 degrees. Therefore this missing angle must be equal to 90 degrees in its size. Those two angles are also defined as one-sided interangles. Therefore the sum of those two one-sided interangles must be equal to 180 degrees. But this is a right angle, so 90 degrees plus this missing angle, in total the sum of those two angles must be equal to 180 degrees. Therefore this missing angle must be equal to 90 degrees in its size. And finally, those two angles are also defined as one-sided interangles. And because of the fact that those two one-sided interangles are located between the parallel lines PQS and ABC, the sum of those two one-sided interangles must be equal to 180 degrees according to rule 17. But this is a right angle. So 90 degrees plus the size of this missing angle, in total the sum of those two angles must be equal to 180 degrees. Therefore this missing angle must be equal to 90 degrees in its size. So in total, inside this quadrilateral PQBA, we have 4 right angles, and therefore quadrilateral PQBA is a right angle. But we also know that the opposite sides of the right angle are equal to each other. So in right angle PQBA, side AB must be equal to the opposite side PQ. But AB is 3, therefore PQ must be also equal to 3 units in its length. Likewise, inside this quadrilateral QSCB, we have 4 right angles, and according to rule 5, this quadrilateral is a rectangle. But we also know that the opposite sides of the rectangle are equal to each other. So in rectangle QSCB, side BC must be equal to the opposite side QS. But BC is 3, therefore the opposite side QS must be also equal to 3 units in its length. In the next step, I call it the big triangle PMS. In the equation, we analyze this big triangle PMS. So actually, this is the big triangle PMS that I call it from the original domain. The red line MQ is defined as the median of this triangle PMS. The definition of a median in the triangle is a line segment that starts from, it connects the vertex of the triangle to the opposite side of the vertex. Actually, it connects the vertex to the midpoint of the opposite side. The line segment MQ starts from the vertex M and ends at the midpoint of PS, that is point Q. So the median connects the vertex to the midpoint of the opposite side. So MQ, the median MQ bisects the opposite side PS into 2 halves. Each half equals to 3 units. PQ equals to 3, QS equals to 3. But the real question is, what is the length of the median MQ? Actually, we have a special formula for the length of the median MQ. So in the domain, we have triangle ABC. The length of this side AB is B units, the length of this side AC is C units, and the length of this side BC is A units. AD is the median of this triangle ABC. It connects the vertex A to the midpoint of BC, that is D. The median AD bisects side BC into 2 halves. Each half equals to BC over 2, and side BD equals to side DC. What is the length of the median AD? The length of the median AD is equals to the square root of 2b squared plus 2c squared minus a squared over 2. Okay, again, the length of the median AD is equals to the square root of 2b squared plus 2c squared minus a squared over 2. We use this new formula in order to find out the length of this median MQ of this triangle MPS. According to the new formula, the length of the median MQ must be equal to the square root of 2 times mp squared plus 2 times ms squared minus ps squared divided by 2. Again, mq equals to the square root of 2 times mp squared plus 2 times ms squared minus ps squared over 2. We multiply this equation, equation 1 by 2, and finally found out that according to equation 1, two times mq equals to the square root of 2 times mp squared plus 2 times ms squared minus ps squared. Here we squared both sides of this equation, equation 1. So 2 times mq squared is 4 times mq squared. And because of the fact that the square cancels the root, we left only with what is inside the root, that is 2mp squared plus 2ms squared plus ps squared. So in total, according to equation 1, we shall find out that 4 times mq squared equals to 2 times mp squared plus 2 times ms squared minus ps squared. So we have 4 times mq squared. But according to equation 2, mq squared equals to r squared plus 49. Therefore, we substitute mq squared here by r squared plus 49, and we have also here 2 times mp squared. But according to equation 1, mp squared equals to r squared plus 25. Therefore, we substitute mp squared here by r squared plus 25, and we have also 2 times ms squared. According to equation 3, ms squared equals to r squared plus x squared. Therefore, we substitute ms squared here by r squared plus x squared, and we have also here minus ps squared. ps in total equals to 3 plus 3, that is 6, so ps equals to 6, therefore ps squared is 6 squared, that is 36. So minus ps squared is minus 36. So here we open the brackets on both sides of this equation, equation 1, and finally found out that 4 times r squared plus 4 times 49, that is 196, so it is plus 196 is equals to 2r squared plus 2 times 25, that is 50, so it is plus 50, and we have 2r squared plus 2x squared minus 36. Here we subtracted 4r squared from this equation, equation 1, so 4r squared gets cancelled here. Here 2r squared plus 2r squared is 4r squared, so those two expressions will also get cancelled. After we cancelled 4r squared from both sides of this equation 1, in this side of this equation 1 we left only with 196. On the other side of this equation 1 we left only with 50 minus 36, that is 14, plus 2x squared. So in total, according to equation 1, we shall find out that 196 is equals to 14 plus 2x squared. Here we subtract the 14 from this equation, equation 1, and finally found out that 196 minus 14 is 182, so 182 equals to 2x squared. Here we divided this equation, equation 1 by 2, and finally found out that 192 over 2 is 91, so 91 equals to x squared. Here we took out of this equation and finally found out that x equals to the square root of 91. The square root of 91 is 9.54. So in total we shall find out that the length of this line segment MF or tangent MF that is equal to x is equal to either square root of 91 units, so in terms of numbers, the length of this tangent MF that is equal to x is equal to 9.54 units. We finished with the first question. In the next step I presented to you the second question, and we solved the second question of this lecture. Our mission in this second question is to find out the length of this tangent AP that is equal to x. We have to find out the value of x. So in the domain we have quarter circle AOB. This is quarter circle AOB, and we also have this small circle. The small circle touches the big quarter circle here at this point. We define the touching point. This point is point K. We also know that this is tangent OB, that is tangent to this small circle at point Q. In addition, we know that this is line segment OQ, that is equal to 5 units in its length. Again, our mission is to find out the length of tangent AP, that is equal to x. We have to find out the value of x. AP is tangent to this small circle is point P. So first of all, we define the center of this small circle. This point is point C, and we join point C and Q together by straight line. CQ is of course the radius of this small circle. We define the radius of this small circle as A. And according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. We define the radius of this big quarter circle as B. So OB equals to B, and OA is also the radius of this quarter circle. This is equals to B. In the next step, we join points C and P together by straight line. PC is also the radius of this small circle, that is A, and according to rule 1, this angle equals to 90 degrees. So in the next step, we join points A and C together by straight line. By joining points A and C, we created the right triangle ACP. So I copied the right triangle ACP in the new page and we implemented the Pythagoras theorem on this right triangle ACP. So actually, this is the right triangle APC that I copied from the original drawing. In this right triangle APC, AC squared, that is the square of the hypotenuse, equals to AP squared plus PC squared. But according to equation 1, in total, according to equation 1, we should find out that AC squared equals to AP squared. AP is x, therefore AP squared is x squared, plus PC squared. PC is a, therefore PC squared is a squared. So in total, according to equation 1, we should find out that AC squared equals to x squared plus a squared. So we have an determinant between this big quarter circle and this small circle, that is to say the touch each other and terminate this point K. Remember, we have a determinant between two circles. You can implement rule 9. According to rule 9, the straight line that connects the centers of the two circles with an internal notch between them must pass through their tangent point. The center of this quarter circle is at point O. The center of this small circle is at point C. And the straight line that connects the centers together is of course the straight line OC. And according to rule 9, the straight line OC must pass through their tangent point at this point K. Again, according to rule 9, the straight line OC must pass through point K, that is their touching point. OCK is one straight line. Again, according to rule 9, OCK is one straight line. So we join points O and C together by straight line. And according to rule 9, the straight line OC must pass for point K, that is their touching point. It is very easy to see that indeed the straight line OC passes for point K, that is their touching point, exactly according to rule 9. CK is the radius of this small circle, that is A. OK is the radius of the big quarter circle, that is B. Therefore, and OC or CO equals to OK minus CK. Again, OC equals to OK minus CK. OC equals to OK minus CK. So OC equals to OK, that is B, minus CK, that is A. So in total, OC equals to B minus A units in its length. In the next step, I'll copy the right triangle OCQ in a new page and implemented the Pythagoras theorem on this right triangle OCQ. So here this is the right triangle OCQ that I covered from the original drawing. We just right now found out that the hypotenuse OC equals to B minus A. CQ is the radius of the small circle, that is A, and OQ equals to 5 units in itself according to what is given us in the question. So in this right triangle OCQ, OC squared, that is the square of the hypotenuse, equals to CQ squared plus QO squared. OC is B minus A, therefore OC squared is B minus A squared, and it is equals to CQ squared. CQ is A, therefore CQ squared is A squared, plus OQ squared. OQ is 5, therefore OQ squared is 5 squared. So in total, according to equation 2, we can find out that B minus A squared equals to A squared plus 25. So B minus A squared is equal to B squared plus A squared minus 2AB. And here it is equals to A squared plus 25. Here we have A squared on both sides of the equation, so A squared will get cancelled, so we cancel A squared. In this side of this equation 2, we left only with B squared minus 2AB. On the other side of the equation 2, we left only with 25. So in total, according to equation 2, we should find out that B squared equals to 2AB minus 25. In the next step we did the construction, that is to say from this point C, we do perpendicular on AO. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point C and AO, this point is point N. By doing this construction, we get the quadrangle NCQO. Inside this quadrangle NCQO, we have 1, 2, 3 angles. The sum of 3 angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle in total must be equal to 360 degrees. According to the rule that says that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside the quadrangle NCQO, we have 4 angles. And according to rule 5, any quadrangle that is 4 angles must be its rectangle plus a square. So we relate to this quadrangle NCQO is a rectangle because it has 4 angles. But we also know that the opposite sides of a rectangle are equal to each other. So an rectangle NCQO, side OQ must be equal to the opposite side NC. But OQ is 5, therefore NC must be also equal to 5 units in its length. Likewise, according to the sum rule, in the same rectangle NCQO, side CQ must be equal to the opposite side NO. But CQ is 8, therefore the opposite side NO must be also equal to a unit in its length. What is the length of the missing 970 AN? AN equals to AO minus NO. Again, AN equals to AO minus NO. So AN equals to AO. AO is B. It is the radius of the fourth circle that is B. Minus ON. ON equals to A. So in total, AN equals to B minus A units in its length. In the next step, I copy the right triangle ANC in a new page and implemented the Pythagoras theorem on this right triangle, triangle ANC. So this is the right triangle, triangle ANC that are coming from the original drawing. This right triangle ANC, A equals to B minus A, NC equals to 12 units in its length, and AC is the missing side. So according to the Pythagoras theorem, on this right triangle, triangle ANC, AC squared, that is the square of the hypotenuse, equals to AN squared plus NC squared. Again, AC squared equals to AN squared plus NC squared. According to equation 1, we found out that AC squared equals to X squared plus A squared. Again, AC squared equals to X squared plus A squared. Therefore we substitute AC squared here by X squared plus A squared, and it is equals to AN squared. AN is B minus A, therefore AN squared is B minus A squared, plus NC squared. NC is 5, therefore NC squared is 20. NC squared is 5 squared, that is 25. So in total, according to equation 3, we should found out that X squared plus A squared equals to B minus A squared plus 25. So X squared plus A squared equals to B minus A squared. B minus A squared equals to B squared plus A squared minus 2 times AB plus 25. Here we have A squared on both sides of the equation, so A squared will get cancelled. After cancelled A squared, this side of this equation 3 we left only with X squared. In the other side of this equation 3 we left with B squared minus 2AB plus 25. So in total, according to equation 3, we should found out that X squared equals to B squared minus 2AB plus 25. But according to this equation 2, B squared minus 2AB equals to 25. Therefore, we substitute B squared minus 2AB here by 25. And in total, we should found out that according to equation 3, X squared equals to B squared minus 2AB, that is 25, plus 25. So in total, X squared equals to 25 plus 25, that is 50. So X squared equals to 50, we took out of this equation and we found out that X equals to the square root of 50. 50 is 25 times 2, and the square root of 25 is 5, so in total this expression equals to 5 times square root of 2. 5 times square root of 2 is 7.071 units. So in total we found out that the length of this tangent AEP is equal to X is equal to either 5 times square root of 2 units, or in terms of numbers, the length of this tangent AEP is equal to X is equal to 7.071 units in its length. Okay, thank you very much.